And next up on our agenda is Mr. Michael Hansen. Michael's the Chief Executive Officer at BarnTools, and Michael's grown up in the pig industry, much like our last producer, Chris, and myself. He has many fond memories. I'm sure we could fill up hours of YouTube video sharing. He's worked in all phases of production, from bore studs to sows to finishing. Michael's got great international perspective. It's just been a couple of months since he and I were on a webinar with a Chinese client that we were chatting with about their air filtration systems and their barn designs. While working at a large production system for the last 12 years, Michael launched a manufacturing business, which has built hog barns and related hog equipment. And today he's here to talk to you about one of his companies, BarnTools. So without further ado, let's bring Michael up virtually here to the main stage. And Michael, I'll turn it over to you to take us through your presentation on practical and proven examples of smart farming and swine operations.
Thank you very much. Just want to make sure you can hear me as well. I didn't follow the rules. I couldn't find a pair of headphones, so just double checking the sound.
Yeah, you sound good to me, Michael.
All right. Well, today I'm talking about practical and proven examples of smart farming in commercial swine settings. And like Dr. Johnson, like you said, I grew up in the industry, and so I put my producer hat on to think like a producer. And there's some key things these producers think about, and I really want to stick to those principles today, practical and proven, and I'll dive into that here. But first, I want to say what's not practical. And I know there's been previous talks about cameras and so on, but in my perspective, a AI fancy camera that can count pigs, to me, isn't practical. The farm staff's already counting pigs, and until you can put a camera in every finishing barn cost effectively, keyword cost effectively, and tell me the exact weight so I know the sort loss at the plant, then I'm probably not interested. I mean, can it scale? Is it affordable? What's the ROI? And those are the things that we think about every time. Now, is this technology great for the future? Sure, but I'm interested in what we can do today. And so to me, the definition of practical is affordable. We're not in these high margin businesses. We're not selling iPhones and all the fancy stuff. We're pig producers, right? And so it's got to be affordable, and it's got to be user friendly. And when I say user friendly, that means it's got to be user friendly for the on-farm personnel. And when I say user friendly, that also means that it gets the on-farm personnel in the barns more time with the pigs than it does interacting with the technology. Because at the end of the day, we want to pay most attention to the pigs. We don't want to be sitting in the office on the computer. And so we really think about that when we build technology and think about the user experience. And then last but not least, of course, is the return on investment. It's got to have an ROI, whether that's hard dollars or soft dollars. It's imperative we have an ROI. And so with the producer hat on, we think about health, we think about input cost, we think about marketing, and we think about labor. And if we can build technology to solve these problems, then I think we're building technology, the right technology for the future. So BarnTools, with that being said, our mission is to turn barns into smart barns, and by automating data collection through farmer affordable IoT. And as you guys probably all know, IoT is any object sensor that's internet embedded that is mainly used for communication or exchanging data. And so if we can put those in barns and turn these barns into smart barns like you would a smart home, we see real advantage, and we can give producers visibility into these barns that are usually located in remote areas, rural areas far away. And we can also start collecting data from these barns and use it in a smart way. And collecting data is step one. And if you do that right, step two is utilizing that data for gains. But you have to do step one right to be good at step two. So before we focus on AI and all the cool stuff, the sexy terms, we got to get the fundamentals right. And that's what I'll be preaching today. And so it's about collecting data, ditching the paper logs, the Excel spreadsheets, and collecting data automatically in real time into a organized fashion where we can then optimize and create efficiencies and predictions for commercial production systems. And it's our mission statement because, if we forget that we need to be practical, affordable, scalable, and usable, then it's not worth our time. It's not worth the producer's time. So stepping back, we talked to dozens of pork producers and we asked, could you give us the basic readings of your barn environments remotely? What we wanted to see is we wanted to see all your barns in real time, not just a sow farm where the fancy, high dollar controllers are, the high end tech's easy to justify in the sow, it's your breeding stock. We wanted technology across the system. So tell us what you could see. And none of them could show us, visibility into their entire system. And we wanted to see that data was being collected seamlessly and recorded in a way that was actionable and across all phases of production. But the reality is we're still writing down temps on clipboards on paper. We still heavily live in Microsoft Excel. And these barn controllers were built with closed circuits, so they never talk to the outside world. And these inefficiencies and latencies in collecting data create real financial losses. And before I jump into the two examples today, I just want to say that if we look why this is, barn controllers were built without connectivity because we never had connectivity in rural areas. We never had reliable connectivity in rural areas. When the cloud was taking off and gaining momentum, we all had broadband at our homes, but the barns were always far behind. And I still see phone lines in barns. Now I see a conversion to hotspots, but these hotspots have data plans, they have bandwidth limits, and you pay for overages, and it's not, broadband is not ubiquitous yet. And so this is really need to be at the forefront of our minds when we build technology for these facilities where we don't put a huge burden on the internet and passing data back and forth. I think one real telling example was after PED, when the industry went through an expansion in 2017, 2018, we built about 200 finishing barns, and we didn't put one touchscreen, $20,000, $30,000 controller in any of those finishings because it wasn't affordable. We didn't see the return on it. And we stuck with the analog controller that we saw, okay, this scales and we could justify. And I think keeping that in mind every day makes me not sway towards the fancy, sexy stuff. We need stuff that's practical. With that said, a lot of the barn practices we see today are residual effects of these old school controllers, alarms, monitoring methods from not having connectivity in the barn. But I think that's changing, and I think animal ag is the last frontier to be disrupted by technology. So we have connectivity now. Broadband with unlimited data is not ubiquitous. So data transmission is something we got to be conscious of, but we're really opening up these farms to be connected. And that's why we built a user-friendly, farmer affordable system called BarnTalk that's got connectivity embedded. We provide sensors, and they're wireless sensors, so we can say goodbye to the install, the wiring. And our mission is, again, it's about sensing, collecting, monitoring the on-farm environment and barn conditions in an affordable way. We don't want to spend $15,000. We want to spend $1,500, and that's the package that we've put together. And this is smart farming, right? So what you can see on our screen here is the hardware. It's the computing power that collects the data, but the real computing power happens in the cloud. And so to us, hardware is expensive. Hardware has limitations. Smart farming and getting to the AI and all the cool progressive technology stuff on the bleeding edge, that happens in the cloud. So we want cost-effective hardware you can put in that at the very minimum transfers data back to the cloud. And from there, we can do some really cool stuff with the AI and the intelligence on the cloud, and then pass that along to the user. So enough of me talking, let's get into some real examples. Example number one is monitoring the barn. And just a quick overview, BarnTalk is our sensor package. We've built a very robust cloud IoT hub or warehouse, as you would like to call it, and then present data right on your phone. You can see all of your operation in real time in a user-friendly way. It's consolidated and it's mobile first. And I always thought, okay, if I want to do something on let's say an alarm system today, I have to go in the barn, reprogram it, probably hold down a button, couple up arrows, it's analog. And so to give that ownership to the farm manager, the growers, and let everyone have that visibility, we allow from this mobile app to change thresholds in the barn, to set off different alarms. And you can do that because the sensors are collecting the data, but we're telling the data what to do in the app, in the cloud. And like a call tree, if I go on vacation, if I change barns, we want to simplify that user experience, really leaning heavy on point number 2, user experience, user friendliness. Let's build that call tree. You can see I'm at the bottom of the call tree because I don't want woke up at 2 a.m. But you could see the call tree there. You can change it, reorganize it, add and delete, all from an app across your system. So let's get to the ROI part. We're monitoring a barn. Barn Tools, our mission is to turn these barns into smart barns. And something like I showed you, or this water meter, is something we have today. You can buy off the shelf. It's real. It's not concept. It's not in trial phase. We have a wireless water meter, and it's one aspect of the barn that we monitor. And what we found is by proactively monitoring water, and I believe a previous presentation, someone mentioned that there's quite a bit of advantages, and there is, because what we found was that if we're measuring water on a consistent basis, and we actually do it in 20-minute intervals, then within an hour, I can tell you if there's something wrong. And over the course of a year, we're seeing about 10% reduction in water usage on each farm across a year, just by measuring, monitoring. We were working with a big production system. This is a real story. We put it in a sow farm. At this point, we were just monitoring. We didn't have any alarms turned on. And the department heads would override the automatic water timers to fill the trough. They'd go home and forget about it, and they'd come back the next day and catch their own mistakes. And we caught that, and we saw them put about $4,000 into the pit. And so that's real money you're dumping into the pit. It's not sustainable. And you can do that because you're collecting data in real time in an automatic way into a centralized system that allows you to do actionable things with this data. So to put that into a visual chart here, what happens is our water meter, it talks to the cloud, and then the cloud, we use AI and some smart technology, and we look for deviations. And when we see a deviation, you get an alarm call. And the alarm call says, hey, there's way too much water being used. And we run off daily consumption, and we have a benchmark based on prior days. At a very high level, it's a rolling average, but it's a lot smarter than that with upper and lower limits. And that power happens on the cloud with no software. That's why we're, again, really passionate about inexpensive sensors. Let's get the barn equipped, but let's get everything to happen in the cloud because it's scalable, it's affordable, and so on. So we track this, and with these analytics, we are able to alert farmers when there's a water leak. But that's not all. So if we take and we say 10% at $0.015 a gallon, and you dump 100,000 gallons into the pit, you just threw away $1,500. For $1,500, you can put a bunch of temperature sensors, this water meter, our smart box that has the internet connected in, all that in your farm, and probably have some change left over. And that happens because people aren't measuring water. And if they are measuring water, they're doing it on a piece of paper or an Excel spreadsheet. And it's each day's an individual reading. There's no correlation to the last. Maybe at most there's a pivot table. But when data is collected automatically and the computer has the ability to watch for us, magical stuff happens. Additionally, we have alarms for lower limits. So if water consumption drops, we can send vets like Dr. Johnson a text message and say, hey, there's probably early clinical signs. Let's check it out. And that's the magic of smart farming. So example number 2, again, these are things that are happening today in the barn at scale that we've seen in commercial systems that we've worked with commercial producers. And the second one is geofencing the barn. So we talked about monitoring the barn, inside the barn, with sensors, affordable sensors, cost effectively. And now let's talk about outside the barn. So first we monitor inside the barn, then we lay a geofence outside the barn. And this helps us capture anything going in and out of the barn. And with that, we can help from a biosecurity standpoint. We can help, let's say it's hourly labor standpoint. We can even, going back to the alarms, we can help with visibility and accountability that alarms are being attended to. So if it's 2 a.m. and a power outage alarm happens, which we all know it's 2 a.m. on a Friday night when most of these things happen, we will actually use the geofence on our alarm system. And if no one, the person who actually acknowledged that alarm, if they don't show up, then we send an alert that, hey, no one's on site. Even if they keep acknowledging it, we say, okay, well, they're not inside the geofence. That location has not been pinged. There's a problem. Someone's not responding. And that brings visibility and accountability that these alarm systems or alarm calls are being acknowledged during emergencies. And then we have visibility, what the alarm is, and so on. Another way we use geofence is for biosecurity. This is our enterprise product. We're actually rolling out a second version of our app where we can work without cellular activity here in a couple weeks. And what happens is everyone's got a phone on them. We don't want to spend money on hardware. We're producers, low margin, affordable. So we use the phone and we use a geofence. And in that, all in a split second, when you cross a geofence, the system will take your last visit. It will take the live health status of that farm, the health status of the farm you're going to, the rules of the nights down rules on your health pyramid, and it will return a yes or no, you cannot enter that site. And that is the magic of smart farming, because now we're connecting processes that were maybe digitized before, but we're digitally transforming this process into a whole new way that wasn't possible before without technology. And with that, you get a preventative approach to biosecurity. You get epidemiological logs and readiness for nights down. You get dwell times for hourly workers in geofences. You get the visibility, like I said, for alarms, and then a proactive biosecurity approach, and then traceability and so on. So we focus, again, inside the barn with technology, and then around the barn with geofence technology, and together we can do some magical things. But to keep beating the same drum here, it's not practical to jump right into these big AI investments or facial recognition for pigs. That's kind of a joke, but I'm sure that it's out there. Let's start with how we collect data on farm. Let's automate that. Let's get the fundamentals right. Let's get the data collection right, how and where, and how it's stored, and then we can optimize, and then we can do some of the cool stuff with AI. And eventually you get to a place where you're beyond efficiencies and you're predicting. And that technology happens by getting the base right, and that's our mission at BarnTools. So that's my presentation, and I appreciate it, and open for questions.
Awesome. Thanks, Michael. Very well done. And thanks to Arjun in our chat, who highlighted that one of the most important questions we have to talk about here is how do we collect the data? And how do we collect the data in such a way that we trust the data? You guys probably talk about this in the production system sometimes, Michael. Somebody says, here's the results. And somebody else says, no, those aren't the results. I don't trust that, right? That data is wrong. And so, junk data in, junk decisions out, right? So if we can improve the volume of data, but most importantly, the accuracy of data, we can make some better decisions.
Absolutely.
You talked about wireless. And when you were talking about the install, you basically said, say goodbye to the install. I'm paraphrasing, but that really triggered my mind because I'm not a mechanical guy. Talk a little bit more in detail about if I'm a producer and I get a package with some of the products you showed in the mail, what do I need to do to get this up and functioning in my barn?
Yeah, so we really thought about install user experience. And what you do is you get the package in the mail, you plug the smart box in, and it does one thing immediately. It finds the nearest cell phone tower. Doesn't matter what provider, so you could be Verizon, AT&T, T-Mobile, doesn't matter. It is agnostic of the carrier. It finds the connection. We provide that for you. So if you have a current alarm system, you can stop paying the $50, $60 landline, the hotspot, whatever it is. And then simultaneously, we broadcast a local wireless using a technology called LoRa. And we see about a 1,200 foot range. And so we're able to equip the big, 7,500 head or 10,000 head sow farms or the single 2,400 head finishers. So you plug that box in, you hang this, and that's your install. You're not paying an electrician. You're not running wires. It's truly wireless, and it's built for barns.
Excellent. You talked about the geofence technology, and that's something that our groups looked at with you guys. To me, all the things that you mentioned are of value, Michael, but one of the other things you didn't mention is the ability to use the geofence data to look in the rearview mirror after a disease outbreak. Producers come to me all the time and they say, I broke with something bad, right? Maybe it's the new strain of PRRS or PED or whatever, and they want me to do the whodunit. They want me to tell them where did it come from and how do we prevent it. And if they have good data on what's come into their farm, I can probably give them a reasonable understanding of what the most likely culprits are. If they don't have any of that data, I can't help them at all. And if we can automate that data, that really is probably the only way we're going to get that today. And I'd assume you guys look at that the same way in your system.
Yeah, we're looking for a smoking gun, essentially, right? And we look at it two ways. We look for lagging indicators and leading indicators. And when you see infractions or violations in biosecurity, those are great lagging indicators, leading indicators to know that down the road, you should essentially see less breaks. And then the amount of breaks is your ultimate lagging indicator. But we look, okay, if something happened, we click on that site, every record's compiled, and we start looking for violations or essentially a smoking gun there.
It's almost like human safety data, right? If you don't collect near misses, it's hard for you to really evaluate if you're getting better unless the actual incidents come down. So understanding those situations where the rules were broken is a great forecasting method to say, are we getting better or not? Because a lot of times the disease outbreaks are the perfect storm, right? It takes everything happening. We break the rules more often than we want to admit.
That's a perfect analogy.
You brought up LoRa, and Arjun's got a nice question on there. Is there cost to producers to using the LoRa system, or is that something that's available for free?
So the LoRa is just the Wi-Fi technology from the smart box to the sensors. We do provide the internet to the cell phone towers, and we say we start out it's $49 a month, and you can put two systems. That's not $49 each. That's $49 for two systems. But as you add systems, that cost drops to about $15 per system. So we're not trying to make a bunch of money. We just want to be able to work with all the carriers to ensure there's some redundancy and backup. But that monthly fee, again, $49 gets down to about $15 by the time you get to the third system.
And it's just working off my smartphone that I already have, right? No additional hardware there?
Absolutely.
All right, very good. Thanks, Michael. Thanks for being a part of it. Thanks for sponsoring the event. Good to see you.
Thank you. Good to see you too.